Now I'm going to start my presentation. Hi, my name is Minwoo Kim, and I'm one of the authors. I'm in a lab in Gaussian University. So let's start. So the title of our paper is a study on the feature selection algorithm based on the measurement method of distance between normal distributions for the classification in machine learning. The human genes have about 30,000 exons that store information. Using a machine learning algorithm on these genes to predict for a certain disease, such as colon cancer or breast cancer, can become quite chaotic. Some genes may be the cause of the colon cancer, but others may have nothing to do with it. Furthermore, even if there is a correlation, it can sometimes cause misjudgment when the relationship is shown insignificantly. So why do the feature selection? Why we have to do the feature selection? Feature selection is the process of determining whether features are useful or not. Therefore, if the goal is to predict whether there is a particular disease by imputing features in the machine learning algorithm, features that are highly related with the disease should be selected appropriately. If features are selected appropriately, then the problem can treat it in the stochastic problem rather than the chaos problem. Most learning models most learning models that we use, like ANN or CNN, RNN, other thing is GCN, they deal with stochastic problem. Regardless of the learning model type, an operation is required to select appropriate features for accurate prediction. As the proportion of unrelated features or noises in the dataset increases, the machine learning converges less, ultimately leading to divergence. So, appropriate feature selection eliminates noise features, prevents divergence of learning, and simplifies models to facilitate easy understanding for researchers and users, as well as reducing learning time. So now I will show you our proposed method we call Gaussian distribution distance. Assuming that the data follow a normal distribution, the confidence interval can be obtained it by using the mean and the standard deviation. If the confidence interval is assumed to be 2 sigma, it is at least equivalent to setting a valid range for the parameter of interest. The confidence interval estimates the probability of the parameter included in the confidence interval, and a 95% confidence interval implies that the level of significance is 0.05. The idea of this study is to use the confidence interval of a group that is estimated to be a different group instead of the p-value. To be able to say that Group A and Group B are different groups, the confidence interval of Group A and that of Group B must not overlap like figure 2a. If there is a section where the confidence intervals overlap, this section is ambiguous, which may be Group A or Group B, like figure 2b. Therefore, if the overlapping section is small, there is a high possibility that the two groups are different groups. A simple equation needs to be created to measure this. If it is required to have no overlap within the range of a 95% confidence interval of different distributions, then the confidence interval of the different distributions must not overlap. This requires to satisfy 1. If both sides are divided by a positive number to sigma I plus to sigma j, the inequality sign does not change. Thus, the equation can be converted into number 2. From 2 and 3, for measuring the distance between normal distributions, can be defined as follows, like number 3. To satisfy a 99% confidence interval condition in 3, sigma I and sigma j have to be multiplied by 3 instead of 2. So these figures shows examples of distance measurement between normal distributions. The mean and the standard deviation of each class are obtained for the features to be selected by applying the equation of distance measurement between normal distributions, and they are applied to 3 to obtain the result. This is the measurement method of the distance between normal distributions. In the case of classifying 3 class types, if the distributions of the samples, like feature values, extracted as the population for each class is the same as in figure 4, then figure 4a will be the best case for classifying the classes using these feature values, because there's almost no overlapping sections between the 3 distributions. In figure 4b, although the first distribution can be distinguished from the rest of the distributions, there is a large overlapping section between the 2 remaining distributions. Therefore, they cannot be classified, or the accuracy may decrease significantly due to the section that is ambiguous. Figure 4C is the worst case among the three examples. In this case, the feature is not suitable to use. In the case of calculating using the equation of distance measurement between normal distributions using binary classification, we need as many calculations as the number of class cases that can be made by selecting two elements from the set of n elements to measure the distance for n classes. The sum of GD, the Gaussian distribution distance in figure 5a, is 6.30, and the sum of GD in figure 5b is 8.67. The calculation result seems to be good in figure 5b, but as it has an overlapping area, figure 5a will better be better choices. The feature selection for multiple classes cannot be performed simply by the distance measurement only. Therefore, an equation that calculates additional points we call AP is required. The AP can be obtained through number 5. If the result value of GD exceeds 1, the distance measurement equation is divided by 100, as shown in 6, to perform the scaling to distinguish it from the value obtained using AP. Specifically, 100 is an arbitrarily set value, and it was selected as the safe value based on the experience because there were cases that the result value of GD was close to 10 in the experiments. It can be adjusted by the experimental. If 5 and 6 are combined, they can be expressed as the modified 7. To calculate 7, the square of figure 5a is 3.07, about 3.07, and that of figure 5b is about 2.09. Therefore, if 7 is used, it is determined that A is a better feature. So I will show you our experimental results. To check the validity of the proposed method, we selected features of the colon cancer dataset. This dataset is a dataset used in the gene expression project at Princeton University. It has information on 2,000 genes selected through the first selection process and consists of data from 422 normal persons and 40 colon cancer patients. When the this figure is normal distributions graph for the top 10 features. When the distribution of the top 10 features were examined, we found that there was no clear distinguishable value between two distributions. However, the bottom 10 features showed almost completely overlapped shapes, as shown in figure A. Table 1 Table 1 summarized the features selected based on different algorithms, the list of top 10 features obtained using the Gini index, MRMR, relational matrix, and our proposed method, Gaussian distribution distance. Table 2 shows the result of one leave one out cross-validation for the features selected based on the Gini index, MRMR, relational matrix, and the measurement method of the distance between normal distributions. In the experimental results, the accuracy shows slight differences, but the result of measuring the time consumed by each method of feature selection showed that the measurement method of the distance between normal distributions required the least amount of time. Experiments were conducted using the Irish dataset to examine the final equation of distance measurements between normal distributions, considering the multi-class classification. The Irish dataset has 3 classes, and each classes has 50 data samples. This dataset has 4 features. Table 3 shows the Gaussian distance score for each features of the Irish dataset. The scores recorded in Table 3 are the scores of the distance measurement between normal distributions shown in Figure 9. Table 4 shows the accuracy when features were selected based on the scores shown in Table 3. In brief, the best result was shown when all features were used. However, while the accuracy was 97% when the top 2 features were used, it was only 79% when the bottom 2 features were used, showing a difference of 0.19. This demonstrates the validity of the method of determining the ranking order. There are more experimental results in our paper. These are lists of our references. Thank you for listening to my presentation. If you have any questions, please send me an email. Thank you.